There we go. And let me just share screen quickly. Everybody can see?
Yes.
Yes.
All right. All right. Well, Happy New Year, everyone. Welcome to the first club meeting of the year. And we got a special guest who's presenting for us tonight, our main topic, Tom Schiller, N6BT. Is going to be presenting our main topic tonight. So rather than doing club business first, like we normally do, I thought we'd push that to the end. So Tom doesn't have to sit through our club business unless he wants to, continue on after he's presented.
He doesn't want to see our dirty laundry.
I don't know.
Darn it.
So we'll push that to the end. So Jojo and Carol, if you're still on the end, we'll cover those topics last. All right. So Tom, if you're ready, we'll hand over to you.
Okay. Now I'm a little bit of a newcomer to Zoom, but we'll try this. So I need to share the screen, right?
Yep.
And I want to share that one. Then we want to do this. Well, come on. From the beginning. There we go. Did everyone see that okay?
That looks great.
Yes.
Yep.
All right. Well, off we go. If you have questions, speak up. I probably can hear you. Otherwise, make a note and we'll get to it afterwards. All right. Good evening. I do enjoy quoting some people like Albert Einstein. The important thing is to not stop questioning. Curiosity has its own reason for existing. And I appreciate your time this evening. Tried to put together a little something about your club, and it was kind of fun. Looks like you had a pretty good antenna there for, was that field day? Yeah, that was kind of a rhetorical question. So, focus on antennas for limited, and limited really means space, time, and budget. Very short bio of me. I've been doing this 30 years. Shipped over 27,000 antennas, mostly HF. First company was Force 12 Incorporated back in '91. Sold the product line in 2008 and then started next generation antennas about 1.5 years later. And been doing things there, primarily focusing on antennas for smaller places. Done a few other things. I've been on about 30 expeditions and done a lot of contesting with Team Vertical and other places. Still hold a couple world's records. One of them is 160 meters, excuse me, the QRP world record on 160 and the world record on 80. And no, I will not try to break either one. So, limited space. Obviously, visual restrictions are simply, if you happen to have a no antennas mandate, that's really tough because it all impacts the most influential part of your radio station, the antenna. And limited space also applies to other things besides your domicile. It's expeditions, mobile, portable, summits on the air, and so on. And I'm really talking about HF antennas, not VHF and UHF. So how do you decide what antenna to get? Well, you obviously talk to your friends, look on the internet, do a lot of reading. And you have expectations and the anticipated experience. But of course, sometimes things get in the middle and the expectations end up not being the actual experience. And remember this old saying, there is no free lunch, and it certainly applies here too. A few basic steps to assist in deciding, and let's do these from the back. Budget. What kind of funds are available? How much installation time do you have? And we have to look forward. How much maintenance might this take? What kind of equipment do you have? What's your location? What bands do you want to operate? And it's very important here to be practical for the limitations you have. And that's determined by your available space where you can actually physically put the antennas. So how do you evaluate one? Well, what do we use? For some reason, actually I have a good idea why. The low VSWR has become the leading indicator of what's a good antenna and what isn't. And my old famous light bulb on the fence post here, that matched to the coveted 1-to-1, so it obviously was a true killer antenna. And as Mark Twain said, I've never let my schooling interfere with my education. But what's the purpose of the antenna? You want to chase DX, get on and work some locals and friends, or get on the air to work anyone? Well, what's common for all three? The answer is length. And that's probably the major factor to be considered unless you have, as I mentioned earlier, this specific prohibition on outdoor antennas. And then there are other things to consider. So what kind of lengths do we have to look at here for HF? Well, I put up free space as well as wire dipole lengths. And obviously 160 takes up a lot of space, 10 meters is a lot less. So for our current conditions, what would I recommend? Well, if we're talking about horizontal antennas, probably 15 meters. It's been very open from where I am in Northwest Arizona, been very open to Europe at times. And 17 meters to some degree, and of course 20 is really always a money band. A lot of people like 40, obviously takes up a lot more space. If you want to do the low band, 75 or 160, that might be unreasonable. 1 octave. So why do I say 1 octave? Well, it means having or doubling a frequency. So what it really means is if you cut a 10-meter dipole, 16.5 feet long approximately, you can actually make it work on 20 meters, which is half size, and have your efficiency around 85, maybe even a little higher percentage. But if you want to use it on 40, wow, now you're 1/4 size. It's obviously going to be very tweaky, very narrow bandwidth. And then, of course, we like to push things. So I say, well, we'll take this little 16-foot antenna, try to put it on a 75 phone, and that's really tough. But we obviously can make everything work to some degree. But let's take a look at what are the good concerns here for short antennas. One is, how do you match it? It's most likely going to either be a very low feed impedance or a very high feed impedance if it's something like an end-fed dipole. Efficiency is always my forte. And due to the electrically small size, the components become very important. And the other thing that your transmitter needs, not necessarily your receiver, your VSWR operating bandwidth. It's how far can you move and keep your transmitter happy. You'll still hear signals on receive, but transmit's another issue. Boy, many years ago, I was trying to remember when this was. Bob Ferraro, W6RJ, who owned ham radio outlets, that was Silent Key for several years, suggested we put together a chart like this, which is your enjoyment of radio compared to what antenna you're using. So we did this one with several people, DXers, contesters, and casual operators, and we came up with this chart. And it was for 20 through 10 meters. And then we did another one for 40. And interestingly enough, of course, if you look sort of right in the middle, what you'll see is a good dipole. Very interesting. Well, what is it about a dipole? It's really nothing fancy. The key is it's efficient. I get this question quite often. Why do people think their antenna works really well? And I put compromised in parentheses because that's usually what the question's about. Well, this is the reason. If I'm point A and you're point B, and it takes 20 dB for me to get to you, and my system has 10 and you have 10, hey, we make it. But if I only have 8 and you still only have 10, we don't make it. I'm on the air calling CQ, nothing happens. However, if you have 12, we make the Q, and I think my antenna and the whole system is working really good. And so the answer to the question is, there are enough stations with larger antennas that make up the missing dB to enable the QSO. They do the, let's call it the heavy lifting. On this chart at the bottom, I had to pick something. So I said, well, the worst antenna imaginable was a light bulb. And back in about 2000, my friend Dean Straw said, "Hey, have you ever tested that? I mean, empirically, really on the air?" And I said, "No." So I entered the ARRLDX contest with the light bulb on a fence post fed with a balun to make sure only the light bulb was the antenna. And I ended up working 28 countries and all continents with 120 watts. There was a good article in QST that year about it. It was called Everything Works. And then my friend Kenny K2KW said, "Hey, can I come over and operate phone?" And I said, "Boy, I don't really think you want to do that." So I said, "We need a bigger antenna." So I made a 3-element phased array, select any 2 phased broadside. I pegged it at 3 dB SLB for gain, which is 3 dB to a single light bulb. We ran 300 watt light bulbs and 1200 watts. We blew out all the light bulbs, really didn't matter. It worked just as well or poorly either way, but he did work. More countries than me, worked 34, plus all continents on one weekend. But the bottom line again is this. When I was trying to get my last continent, which was Africa, I knew there was one station there who could hear me, if anybody could, and that was Jim Niger, N6TJ, operating ZD8Z. And I just waited quite a while, finally found him. Took me a half an hour of calling, but he finally got me. And so, I got this little light bulb sitting there, and he's got this massive array over there on the west coast of Africa. And he's really the one that made the cue. So an interesting question is, what's your antenna EQ, your environmental quotient? What that means is the antenna really is a whole system. It's not just a physical antenna. It's the actual location, the close location, and what else is around you, what kind of buildings there are, what the terrain is like. So I happen to be watching this really good build it video on YouTube, how to build a fan dipole. And I thought, boy, I might even want to recommend this to folks who want to build a fan dipole until the end. And at the end, what he did, he said, "Let's test it." So he put it on the end of a rope on a halyard, hauled it up his tower, and he has the feed point right below the feed point of his G5RV, about 1 foot away, and he's making comparisons between the 2 antennas. And the point is, he really did not have 2 antennas, he had 1 with 2 feed lines, because they were so close, they were coupling to each other. And that brings us to maps and aliens. In general, when we look at antennas, we see these patterns and we think, "Oh, when I put it up, it's going to look just like that." Not necessarily so. We just presume, well, at least the plots presume, the antenna is all alone, but what if it isn't? So what do antennas actually see? Well, we need to remember that even though it's a mechanical structure, it's actually first and foremost an electric device or electrical device. And to operate as we expect, like we see on the plots, it needs to be in the clear. But what if it isn't? So we have this term standoff distance that Ward Silver came up with for me, which is how far the antenna is from other surface or structure, including everything, before it gets distorted. And can you test to see if your standoff distance is adequate? And that's where MAPS comes from, stands for my antenna's personal space. And it all has to do with proximity. So a starting point can be, if you're building a Yagi antenna, how far in spacing can you put the elements in the Yagi and still have it work? Well, the answer is at least a quarter wavelength. So if we look at that on 40, it's 35 feet. Keeps getting smaller, of course. On 10 meters, it's only 9 feet, but there's a catch. This isn't in only a horizontal direction or in a planar thing. It's a sphere around every antenna. So if you happen to have this kind of an installation, if you have limited space or an HOA, you probably don't have this. But if you have this kind of a stacked array, this is what you're dealing with for standoff distance and how far away the antennas can influence each other. This particular setup was done perfectly well. And his 40-meter antenna was set up so that it did not interact at all with 15 on the antenna right above it. So when we put up the antenna and there's an object within the antenna standoff distance, we know that they're going to talk to each other. And the bottom line is, what does our antenna actually look like? Well, our actual antenna is what we put up, plus everything else within its standoff distance, and maybe even farther. I put up a 5-element 20 one time for a fellow, and he had an old high gain tribander about, a good 300 feet away. And when he was aimed at that tribander, it disrupted his big monobander to where the tribander was actually better. Any other direction, it was the other way. So the actual antenna, when we have something within this distance, is unknown. And excuse me, I refer to it as an alien antenna. For example, how high is this Yagi? 25 feet, right? Except it's by our house. So now, what is the actual height above ground? Well, it sort of depends on which way the Yagi's aimed. Part of the elements might be, a few feet above the roof, and the others are 25 feet. So if we take a look at the standoff distance, besides that, this antenna might well be seeing electrical things and other stuff that's actually in the roof. So now what happens? Well, the frequency is usually pulled low. The feed point's also affected because it includes everything that it can couple to, unfortunately. Well, then what do we usually do when we have this? We want to get on 40 meters, so we add a 40-meter inverted V. And of course, we generally have to put it in this orientation. Well, now, what does our antenna look like? What does our 40 look like? Well, it looks like this. So now, our 40 is probably talking to the whole house. And if we have sprinklers out there, electrically controlled, they're probably talking to them too. I one time put up a big antenna system for a fellow, and he was running an amplifier. And every time he was on 20, his neighbor's sprinklers would pulse. They'd just pop up in the air. And I was able to fix it, but nonetheless, it was kind of interesting. But this is the alien antenna. So now, what if we have this? Fortunately, where we are in Arizona, we don't have these, but I've certainly lived places where we did. So we'll just throw this in the backyard here. And now, this is what our 40-meter antenna is probably looking at, all kinds of things. So it's truly an unknown antenna. And if you look online, you will find some what I would call home antennas with various claims. And this is one where you start off with a house and you make this perimeter type antenna where it goes all the way around the perimeter of the house. It's fed in the middle on one side. It's got a resistor on the back side. I would please ask that you do not do this because I would call it the ultimate alien antenna because it's talking to all the heating ducts, wiring in the whole house, everything. The metal siding, stucco, whatever it is, gutters, downspouts, the whole smash. Plus, if you have concern for FCC exposure limits, probably not too healthy being inside there. So the few basics, if we are limited physically to something, what is it? It could be limited horizontal length, limited vertical height, or visual. Or it might be that we have to have everything inside, which is really tough. If we have a balcony, that's an asset. And if we have access to ground, that's a great asset. So my off the top thoughts for antennas with these things, if everything is inside, I'd suggest a magnetic loop. If you have a balcony, a mag loop or a compressed vertical or dipole, if you have access to the ground, that opens a whole lot of more options. And the magnetic loop, of course, is a low profile antenna. You can make one or you can build one. They've been around about 100 years. There were a lot of them built back commercially in the early 90s, I think. And they seem to be gaining popularity again today, maybe because of all the HOAs. But what are the issues with them? One is that they have a very narrow operating bandwidth, just a few kilohertz, and they're limited at power handling. A lot of them are only rated at 15 to 25 watts, some even less. Now, a plus side to these is that my experience with magnetic antennas is that they're less sensitive to the immediate surroundings, which is why I suggested it would work indoors, because I've done this many times. So a couple that are on the market, for example, the top one, 40 through 10, $230. This may have been pre-COVID. I can't remember when I first got these prices, but we'll just use them. So about $230, rated at 20 watts sideband, 10 watts, CW and digital. The one below it is $330 more, same frequency coverage, but what do you get? Well, it's rated at 150 watts. So what's the difference? Well, it's what's in that big thing, in that antenna. This is from an old AEA. It's a butterfly capacitor, and this AEA unit was rated at 150 watts. There's a motor drive on the left, and I have this. I'm not currently using it, but no, it's not for sale. But the other way you can tune them is by using a big surplus vacuum capacitor. They can be very expensive, plus you need a mount and a drive unit, but this is how you tune a mag loop. If you want 40 meters, and you want it broader banded than a 3-foot loop, which is the ones we were looking at, handle at least 100 watts without vacuum caps, and you can even make it visually lower when not in use, you can actually build this guy. We built many of these for people. It's a 7 by 9 feet. It sits on some homemade PVC stands. It just pivots there. It's tuned with some shorted coaxial stubs, so it's not frequency agile, but it will take easily 100 watts. It's a good 25% efficient on 40 meters. And of course, you can just tilt it and get it much lower to the ground when you're not using it, be about 3 feet off the ground. Been a very, very effective antenna on 40. Plus, it'll work on some other frequencies above and a little bit below. If you have a bigger budget, you might consider these. These are pretty new on the market. The baby here covers 40 through 10. It's only $2,100 plus options, but it's rated at 450 watts on the higher part and 1 kilowatt at the top end of the tuning range, approximately 12 and 10 meters. It's 40 inches in diameter, and coincidentally to the 7 by 9 foot, it also uses 2-inch diameter aluminum tube for the ring, or for the loop in this case, or circle. They also make this guy called the MIDI. It's a little more, about $400 more, but it'll go all the way down to 75 meters and 80 meters with 300 watts. And it's also made with 2-inch diameter aluminum tube. And in both of these cases, I would highly recommend you put a rotator on them, because these antennas, magnetic loops like this, have a figure 8 pattern, and the nulls are quite deep at times. Well, what else might this company have, this Italian company? They have this guy. Now, to me, this looks like a big scissors jack, and I haven't tried one, but he calls it the stealth loop. It's only 1,800 plus options, 40 through 10. It has to sit on this metal plate. That's how the VSWR is adjusted, but it will cover 40 through 10 meters at 125 watts. And all 3 of those antennas are remote tuned, so they might be attractive to some folks, if you have the budget. Certainly, if you had this one up, I don't know what anyone would think it was, maybe yard art or something like that, but it might end up working fairly well. But what if you want to just put up a wire, just put up something? What's the most efficient symbol antenna? Well, a half-wave dipole. We read that in the ARRL antenna book a long time ago. It has equal quarter wavelength halves. You can feed it with a 1-to-1 balun to keep the coax out. Works great. What's the most efficient multi-band antenna? Well, coincidentally, it's very much like that one, but it's fed with 450 ohm open line or some kind of open line and a tuner. In the old days, it used to be called an all-band doublet. You can find a lot of information from the late LB Subic W4RNL. He has a lot of data on this antenna. Very efficient. Of course, it needs to be elevated. And If you're only at 20 feet, you get basically the patterns on the left, 40 feet in the center, and 60 feet on the right. Now, these are all for a 135-foot doublet, meaning for 75 or 80 meters. And we are looking at the takeoff angles. So we're looking at it from the side. So obviously on 10 meters, the angles get lower the higher you go. It happens on all of them, but at the real low heights, like 20 or 40 feet, if you have limitations, your best performance is going to be, of course, on the high bands. Well, now if we take a look from above, the so-called bird's eye view, this is what we have. Now, since it's a single wire, you probably think all the time that the pattern is a nice figure 8. But if you look at the high bands, the lower 2 sets of 3 lines, you'll see that's not what you get. You get all these things coming off like in all 4 quadrants. So sometimes your antenna might feel like it's working great. Other times it'll feel like it's not working at all. So the main issue with any of these horizontal antennas, you need some height. And even getting one up like 35 feet in these examples might not be feasible. So if you want to work DX, get a good signal across the country, what's probably the best antenna? Well, I almost forgot. We have this guy, which has been gaining in popularity, the EFHW, or the unfed half wave. So it's a half wavelength wire fed at the end, which makes the feed impedance really high. It has a 49-to-1 matching transformer there. It's not a balun, and it has a very short counterpoise. So what do we get for that? Well, we need to remember that it's still a single wire, even though it's fed at the end. So the pattern is going to change depending on what band we're on and its relation to the length of the wire. As a half wave radiator, it'll look the same as a half wave dipole. And as length increases, we get these strange things just like this. These are the patterns you can get off of an EFHW, very similar to what we were looking at before on the multi-band dipole. So the pattern really depends on the overall length and the frequency of operation. The counterpoise, as I mentioned, is very short, very small. I mean, really short, like 2 or 3 feet. And the box contains this matching transformer. I have yet to see one with a balun, so perhaps that implies that the coax feed line is actually part of the antenna. These are the most popular EFHWs, or sorry, horizontal antennas. Most of them are EFHWs, the bottom 6 or so. And what do they have in common? What do they have not in common? Well, the patterns are all basically the same for a given height above ground. They all need supports. The differences are a dipole on its primary band does not need a tuner. Everything else does, one way or another. So if you need to make a short antenna electrically long, meaning need to load it, what do you make the loading coils out of? Well, the best are air core. There are a lot of commercial coils wound on PVC. Some of them are wound on black plastic material. And these days, I really have no clue what's in that black material. There are some other cores that are ceramic and so on. The caution on the black is that it might contain graphite, so it's a conductor. And that's certainly not where you want a conductor as the core for your coil. And the reason is a lot of that material comes from Asia, and the content really is unknown. And I had to add a comment here on what I just call black stuff. Some people like to use bungee cords for a lot of things. And I was working on a 160 antenna for a fellow. He called me up and he said, boy, I smell something burning out there. So we went out there and he had several bungee cords holding this big coil and some capacitors. Well, the bungee cords are conductive. Whatever is the black stretchy stuff inside apparently is not an insulator. And as he was transmitting, the bungee cords got hot, started to smoke, and they actually melted. So be careful what material you use. But where's the best location for coils? I choose close to the center of the feed point because that's the highest current and lowest voltage. and it also requires the least inductance for resonance. As you move the coils farther away, the current decreases, the voltage increases. It's much more difficult to handle high voltage, and you have to have more inductance. The comment in white print at the bottom is something you probably haven't seen before. If you, for example, have a 40-meter dipole that's short and you're loading it, the coil location where you put those can make that 40-meter dipole not resonant anywhere near 15 meters. You can actually model this stuff. So you can make a short antenna and be able to put it near something else and not bother the something else. So when do you consider a pattern? Well, if you get on the air with something, plasma patterns probably not worth, it's not much of your concern. But if you're chasing DX, it obviously is. Now, how do you get directivity? Sometimes unknowingly, we take these other patterns here, the following ones are from a G5RV. If we look at it on 20 meters from the side, this is at 25 feet, it looks pretty good. If we look at it from the top, it's not. The energy is actually going off into 4 quadrants, not the direction that we want. How about 15 meters? G5RV now, 25 feet. This looks really good for a takeoff angle until we look at it from on top. And in this case, again, you're going to have some energy in all 4 quadrants, pretty narrow. And if someone happens to be at one of those lobes, the antenna will seem like it's working great, but then you got all these nulls all the way around. So how do you intentionally get directivity? Well, it's simple. You need to redistribute or redirect the energy. No free lunch, remember? So we start with the original dipole. And if you are making a Yagi, you add a couple elements and you just push the energy off to the right at the expense of the energy going off to the rear where it used to be. So dipole, what kind of wire do you use? Probably would always assume copper or copper clad. And if you happen to find some copper plated wire, please do not use it. The plating is way too thin, and the current will go right through it and into the steel core. There's also a stranded flex weave, which seems to be pretty good. Each strand in there is actually clad, and there is actually a spec on cladding if you want to look it up and see how thick it has to be. What not to use? I keep beating this drum, so to speak. Do not use stainless steel. The coil in the picture there was an experiment. I put up a big 3-element 40-meter for a friend of mine. And I said, do you mind putting this, if I put this hairpin match on here for like a month, and then tell me how it was. After a week, he called me up on the phone and he said, will you please take this thing off of here? He said, this antenna is like a piece of wood. Well, he lived 300 miles away, but I drove up there and changed it out. But that is the actual hairpin coil with the little bitty of operating that he did during the week. And as you can see, that stainless wire got really hot. It was incredibly lossy. If you wind a coil, an air core out of copper with a Q of 600, if you use stainless wire, the Q will be less than 30. So do you have any stainless in your antenna? Well, we test a lot of antennas. A lot of times with drones and sometimes with static devices. So I decided to test an old 5/8 wave stainless mobile whip. And then I had this idea that what if I took some tinned copper braid and just slid it over the top? Would it make any difference? So yes, test 1. I used 100% braid over and I picked up 1.8 dB. And I said, well, it had so much braid on it, you know, it wasn't kind of whippy enough for mobile. So I used only 50% braid over, as I called it. I picked up 1.44, almost 1.5 dB. And then I did 1/3 down at the bottom and I picked up about 3/4. So what I'm doing with this antenna now, I have the braid halfway up and I know that I picked up about 1.5 dB. Well, most people probably look at 1.5 dB and think, that's not much. Well, this whole whip antenna actually has almost 2 dB loss. So is 2 dB a big deal? Well, when we're in our example path, obviously it was, at least in the example. And one of the questions that's relevant is, how sensitive are receivers today? Well, they're a fraction of a microvolt, meaning a fraction of a millionth of a volt. It doesn't take much for you to be heard, except there's a catch. You have to get something to point B in order to be heard. So that's really the key. This chart is most important. Please pay attention on the next two slides. When you're doing this, there's a lot of writing on these two slides. But 2 dB is so important when you're portable. If your summit's on the air, field day backpacking, using temporary, very temporary stations, when you're running QRP, if you have limited resources, which means people and available structures, the time of day that you're able to operate, the weather can control your operating time, and the terrain, very important. And the biggest one probably is your available time for setup, operating, and takedown. That even includes field day. So all the above really means you need to maximize for the biggest transmit signal you can get, because you have to get to point B. You will always hear enough stations coming back because they have bigger and more efficient stations. So with almost any antenna you can hear, if signals are 20/9, that's probably not an issue. The key is, how strong are you at point B? 2 dB, in my opinion, is a ton. Team Vertical, we set over 25 world records. And what the team finally decided was, if we could get 2 dB from an antenna, or anyhow, it gave us another layer of stations to work. It wasn't a few, it was an entire layer. And that's how we actually ended up setting all kinds of records. So we do test antennas. And this little guy, very popular. There are several designs like this. It has aluminum tubing at the center, 2 adjustable coils, 1 on each side, and then these telescoping chrome tips. So we set it up for 15 meters. Said that'd be interesting, and we did measurements there. And then we replaced the telescoping chrome tips with aluminum. We made aluminum, and then we threaded the end so it could screw into the coil. And any difference, you think? 3 dB. That's amazing. It's just changing the tip material. It was quite astounding. The same antenna can be configured into other bands, one of which, of course, is 40. So we set it up according to all the instructions. We actually even called the company just to make sure we were setting it up right. And we had a 31-foot copper radial, solid copper. We set up the vertical just fine. It matched fine. And then the comparison antennas used one of it's called a Bravo series. The vertical part was exactly the same length as the other one, except that instead of a 31-foot copper radial, it had 2 9-foot tubing radials that were loaded at the center. And we flew our drone through the pattern 4 times. We had about 6 people watching this. We did it once and they said, that can't be. And we did it again. And anyway, we ended up testing it 4 times. And the difference was 12 dB. And to this day, I really do not have a good answer as to why that antenna was 12 dB down from the other, except it has a lot to do with efficiency, and that the one on the left there also was using these telescoping chrome tips. They were longer than, I think, on the 15-meter ones, but nonetheless, there were components in there that were very lossy, and the overall construction may have left something else to be desired. So if you want to get on HF and work, folks, sometimes long distances, well, you can make some good antennas. You'll probably be running low power, and my suggestion is to not run QRP. Even though I hold 2 records on QRP, I don't suggest it. It's not much fun. Running more power is, because the lower power you run, the more important the antenna. And just like the charts, the antenna is directly related to your enjoyment of radio. My old friend Bruce, N6TU, back in the late 70s, coined this phrase, life's too short for QRP. One of the most restricted HOAs I ever worked with is this one. And this also deals with a subject later on called camouflage. He really wanted to get on the air. This weather station on the tripod is guyed with 4 wires. Well, 2 are not wires, they're non-conductive, but the other 2 are a 40-meter inverted V. And it actually worked pretty well. Of course, he would like to have gotten on the higher bands. So finally, we acquired a trapped dipole from a tri-band Yagi. And we mounted it 1 foot off the roof. I welded up some ballast trays for concrete blocks. We had to do quite a few adjustments. Then we moved it around on the roof so you couldn't see it from anywhere. Finally got a reasonable match. He's running a kilowatt ICOM solid state setup, and it worked for him. He also has a small listening loop on 40. And the key is that even though this antenna is not too great, it's out in the open, in the clear, sort of in the clear. If you want to put up a dipole, which I've already mentioned is a really efficient antenna, you can bend the ends around a lot. They model really well. Now, if you don't have space, you have to go up. So that leaves you with various kinds of verticals. There are a lot of trapped verticals out there, a lot of different kinds. They appear mostly to me to be concerned with having a low VSWR on the bands. My main concern is performance. So starting in 2014, we started flying drones through antenna patterns. This guy's become somewhat iconic, the high frequency flamingo. It's actually self-resonant on 12 meters. For this test, we loaded it down to 15. And this fellow who is watching this right now, this is pretty innovative. A 2-meter plasma flamingo. And apparently it does work fairly well. And then we have a couple of these in the backyard. They're a lot smaller, but maybe you could phase them and make some kind of directive array on 432 or something. But we've done a lot of empirical testing using drones, dynamic and static signal sources, measure takeoff angles for all kinds of verticals, all kinds of ground, different kinds of terrain, salt water, all kinds of things. And I can verify that all this data is very accurate and you actually can reproduce it yourself. So a short list of discoveries to date about vertical antennas, which covers about 25 years. Page 1, 1 through 9, and 1 through 19, or 10 through 19. We won't read them all. We'll go to the gold page. And this is really the keys. The classic vertical, if you put up a quarter wave vertical with like 4 radials on the ground, compared to what I showed you earlier, that Bravo antenna, you'll be 7 dB down. The takeoff angles for verticals, when they're calculated on most models like NEC 2, AO, and Mini NEC, and so on, they are incorrect. The takeoff angle is much lower. For example, all the antennas at our place in Northwest Arizona, which is desert, they are all 12 degrees, and we have no radials on the ground. Verticals by salt water will have energy down below 1 degree. If you have a vertical adjacent to sloping ground, the energy follows the slope. And for each degree of slope, it will lower the takeoff angle about 1.1 degree. The number 9 there talks about this ground reflection gain. If you want to read about that and see all the math, look up ON4KHG. And he will show you mathematically and in other ways that it's really a myth. Verticals also have, in quotes, let's call it ground gain. The VOR, the vertical open ring, which I'll show you in a bit, is as effective as 2 full-length gull-wing radials or straight radials. They're within 1/10 of a dB, and it takes up a lot less space. And as you saw earlier, with the flamingos, verticals do not necessarily need to look like an antenna. So what can you make that will work well? How to make one without buried radials. So assess your area, the possibilities you've got, decide on 1 or maybe 2 bands, and keep your limitations in mind. A vertical does need something for a current return. If you're interested in the low bands, 160, 80, and 40, those are tough. But one solution here is called the FCP, the folded counterpoise by Guy K2AV. Looks like this. It goes back and forth, and then it's fed with this isolation transformer. I've heard them on the air, and they are fairly effective. This is how much space you would need. For 40, it's not too bad. It's only 18 feet horizontally. For 160, it's 66 feet, but of course, you also need to go vertically. So for what I've been working on, that was still too large. So I went back over all of the antennas we've made, particularly for Team Vertical. The regular antennas, let's call them, with gull wing radials, the Bravo series that we developed, the Sigma series, looks like a big letter I, made those commercially. We also did antenna called the ZR. And I finally went back to that one and resulted in this guy. The original prototype was in the upper left corner. It was developed by Dr. Joe Boyer. I wrote a spec, and that's what he sent me. And that first came into production in the middle there as the ZR3. And I kept looking at that, and I said, okay, I'm going to take off the top rings and make the radiator full size. And then use a quarter wave ring on the bottom. So the lower right is the first one I built back in 2017, I think. It's an open ring on 40. Been using a 4-square made like that ever since. It's been fantastic. And we've done extensive testing. You can do computer modeling too, and what you'll find is that the open ring is truly within 1 or 2 tenths of full-length gull wing radials that are elevated correctly. So the open ring looks good on efficiency, but one good test is worth 1,000 theories, right? So let's go through some testing. And these slides have a lot of data. I'm going to go through them pretty quick. So I did 5 different tests. This was last summer before I had my heart problem, fortunately. And it was very hot in the desert there when I was doing this. So I was up, oh man, before the sun was up, like at 5 a.m. And the first thing I did, I made a 2-element 20-meter vertical. It's on the right. And this has a full-size 20 with an open ring. And I compared that to one of my own antennas. It's a 5-band Yagi. And what I found was that it actually wasn't too bad. The vertical array was usually behind by about 2 dB every once in a while. They were actually equal using the reverse beacon network and some other things. The RBN is a little tricky, but overall, it was encouraging. So let's compare verticals with verticals. So we just set up this test array, and we started off with a classic system with 4 full-length radials and flying the drone up here. This is with all 16 cut to 70%, which is what N6LF suggests, and which is what we found too, because a quarter wavelength is too long. They put the maximum current in the ground instead of in the antenna. So if you think you've seen this picture before, you might have. If you have seen the Australian standing stones, they do kind of look alike, but really we're not using the stones here. So just 16 rocks. So we test this, and how did that tune? How did it tune up? Well, it tracked N6LF's data right to the T. With 4, the frequency was 19.5. It wasn't on 15 meters, which means that the radials are too long. It's pulling the current into the ground, and that's why you're going to lose energy. So then what do we usually do? Well, gosh, it's at 19.5. Let's shorten the vertical. Well, then that just puts more current in the ground, and you keep losing. So the next thing was to add 4 more. So we did that, and we tracked it, and it certainly did move the frequency up. Now, these were full-length FLRs. We call them full-length radials. And the improvement showed 2.56 dB. Well, Rudy's showed 2.26 dB. I think that's probably close enough. His ground was really good. Ours is desert. This is Rudy's chart. And so far, we're tracking right with it. So now we need to do the open ring. And did a lot of tests with this. the open ring by itself, the open ring over the radials, and then so on. And the bottom line, well, first of all, if you take the classic vertical again with 4 cut radials tuned to the right length, the open ring is almost 2 dB better. And we just kept going. And overall, the open ring, just that one single ring, which is a quarter wavelength in circumference approximately, it's equivalent to 16 cut radials, almost identical to it. And if you put the radials underneath, you pick up about 0.2 of a dB. So overall, the open ring, a very efficient technique. And if you take Rudy's chart there with circled in the bottom, is the difference between 16 and 32 radials. It's about 0.1 of a dB. So if you want to use an open ring, I would hazard to say it's about equivalent to having 32 ground radials that are the right length. So earlier in this presentation was the first slide. At the front of our property, we set up a vertical field, and we were trying to put it into as small an area as possible. It's only using about 1/2 an acre. So what do we have here? There's 4 elements on 40, 3 on 80, and 2 on 160. The 80 and 160 are phased arrays. There are no ground radials. Every one of these uses an open ring. And that's the arrangement where they are. I know I'm going through this kind of fast. With the open ring, it's like they're on 160. Actually, on 160, I use 2 parallel wires to simulate a bigger conductor, and it gave me a little more bandwidth. Nice aerial shot there. So you can really cram this stuff in if you want to. If you want to do 40, this is really the way to do it. You only need a 4 square is only 48 by 48. If you want a single vertical, it's about 8 by 8 feet. That's all, and nothing on the ground. You can also make all kinds of other things using this technique. You can do a 3/4 size 40. You can do multiband like this one, relay switched for 15, 20, and 17, very small. If you want to do something bigger, this is an 80/40. It's actually a full size 40 with a ring that's 7 feet on a side. And then it has a powered tornado drive in the center to tune you down to 75 and 80 all the way across the band. And that 80/40 is sitting right there in the front yard of this fellow's house. And it's good. So what else can you use for small space? There are lots of flagpoles out there. A lot of them use tuners at various places at the rig where the coax enters the house. You know, where do you put the balun? These questions here, the bottom line is F. It depends on the whole situation. So utilize terrain to your advantage. That's really a good suggestion. If you have sloping ground, put your vertical as close to the sloping ground as possible. As I said, we started doing this. Our first testing was with helium balloons on the left there, but we used drones. We actually used 3 drones. The reason we've used 3 is that I crashed the first 2. Steve Stearns did me a real favor here using some sophisticated modeling software called Hobbies, just to show that using, let's call it up-to-date modeling, does show that the vertical antenna will follow the terrain. And this is just one of his plots. He actually gave me a complete set. So remember that HOA with that trapped dipole? I always wondered how good a dipole was. So we set it up and did some testing. We'll zip through these kind of quick. You can figure out how high you need to fly. It said we had to fly at least 120 feet. So actually we went up 150. And the trapped dipole compared to full size was 0.8 dB down. I was impressed. So then I said, well, let's see how much the 3-element Yagi has. And the 3-element Yagi had 2.6 dB over a dipole. I actually think that's not too bad. But it was a question I had for a long time. So remember that dipole, that HOA was only a foot off the roof, but it got them on the air and it worked quite well. So what else can you make? Don't make this one. This is what I call the classic vertical that I grew up with. try to make it without ground contact. If you can make a ZR like this, the original prototype from Dr. Boyer was actually done with copper tube. The radiator on the left there was 3 feet tall. The rest made a full half wavelength on 20 meters. The ZR3, I've got actually 2 fellows that watched this presentation at Pacificon, and they actually have been working on making their own ZR3, kind of using their own designs. I mentioned camouflage before. The HOA stuff is on the left. You can also paint it like the ZR3, or you can also allodyne it, which gives it, well, it comes in colors. In this particular one, allodyne is kind of this goldish brown color. And if the ZR is too complex, you can make this Sigma style. These model really well. It's just a big letter H on its side or a big letter I. Make them for all kinds of bands. You can center load them like this. Very easy to make. Or you can even use some relays. And this is my old Sigma 5, runs 20 through 10, actually handles 1500 watts. The Bravo series, these are also easy to model. The advantage with this is the feed point's at the bottom. So you don't have something coming up in the center of the antenna or elevated somewhere. The tricky part is when you have to go 90 degrees. But you can use some angle stock. And if you have someone who can TIG weld, just weld it at 90 degrees. Or you can get this piece of plastic, which is used for, I guess technically I should say PVC. It's primarily made for furniture, but you can drill out the bottom and then use it like this, and then use PVC for the spreaders, making an open ring. This happens to be on 20 meters. This guy here, I just nicknamed the Viper 98. It's a new one I've been working on. It has a full-length 20-meter radiator in the center, and then wires going up for other bands, and then individual rings. And the 98 means it's 98% efficient. And I don't know, I just picked the word Viper. It started with a V and it's a vertical. So you can also build this kind of thing, the EV series. I have a lot of plans for these. These are actually, this is a 2-element rotatable 5-band vertical. And one thing I've learned is that you also want to have the current in your verticals balanced. I intentionally unbalanced this one. Actually, I think I showed this at Quartzite one year. And just by changing one piece in the physical construction, I lost 9/10 of a dB. It was pretty impressive to me. So a word of caution, antenna high voltage. The ends of dipoles can start fires. I've started 2 roof fires over the years with the shingle roofs. And if you have something in your balcony, same thing. Make sure the ends are really well insulated. Magnetic loops. The reason those capacitors are so expensive is they have to handle incredibly high voltages. And if you have any perimeter wires, like going around the house or something, be very careful where that high voltage is, and have some reasonable expectations of the results. So, general rule, if we remember about the standoff distance, less is better. Fewer antennas are better. Lower power, the more important your antenna, especially on the low bands. If you want to get more gain, what's the easiest way to do it? Add one more element. Physically and budget-wise, it's the best way. If you happen to have an antenna like this, I'm not sure this one's going to work. Yes, it is. And you want to really hide this from your neighbors. Now, obviously, we don't have anyone too close. This is using a 12-volt actuator, a wireless controller, and it will lay the antenna right over. And then also, of course, you can raise it back up. So it can be down when you're not using it, and just crank it back up and you're ready to go. I think I got to wait for the video to end before I get to the next slide. So, okay. These 2 rings, that particular antenna, I moved to another location, and it has 7 concentric rings on it, 40 through 10. No other wires on the ground. So remember the gold page, all these main items and thought for the day, everything works to some degree or other. Think out of the box. And unfortunately today, there's a lot of FT8, the ARRL, I think last year, or maybe it was the year before, they said, I think 65% of all the contacts on HF were FT8. Yeah, it was 2020. Interesting. And I always like to remember and remind everyone, the future of amateur radio is the youth. And appreciate your attention. I saw my book, Array of Light, on your webpage, or whichever webpage it was, I can't remember, sorry, Array of Light. That's still available. My new one called 30 Years in a Light Bulb, I'm almost done with. Well, almost, we'll see. So that'll be coming out for soon, I hope. So thanks very much. You've been a great audience.
Thanks, Tom. Lots of stuff to think about there. Does anyone have any comments or questions for Tom?
Oh, I do. I'm Tom Cutter. Thanks for doing a presentation with us. And anything you talk about, you inspire others, you have no idea. So I'm now thinking about using copper wire on a spider beam pole as some kind of antenna. I'm not sure exactly how much copper I need. I know that copper tubing will not do very well in the wind. So I was wondering if you had done something like that, using a spider beam and some wire for a vertical.
I do have an antenna I bought. Has anyone here watched DX Commander on YouTube?
Mm-hmm.
I actually bought one of his antennas to see what it was like. The shipping, I think, cost more than the antenna. But anyway, the centerpiece is all telescoping fiberglass. And with the way aluminum pricing is today, that might be the best way to try to build things. So that particular antenna just has this, it's about 33 feet tall. Then it just has a lot of wires coming down. He lays down a lot of radials, but the construction using the fiberglass, not a bad idea. On my open rings, I've been using both PVC and fiberglass to try to get away from aluminum. I was just pricing it the other day, and I'm kind of astounded as to what it is. A lot of the common suppliers, I think if you buy 6 feet of 1 inch, it's almost $3 a foot. So sometimes we have to be more innovative, even though on the components, just like Tom was saying.
Your copper braid gives me an idea that I saw you're using a lot of aluminum for your verticals. It now makes me think that, you know, you get copper in there, any bit, it seems like it'll do some good, making it efficient.
Yes. Yeah, copper is a great conductor.
Thank you.
As a matter of fact, let me augment that. A friend of mine back east, as we've been collaborating really on his 160 verticals. And he has a lot of radials on the ground, number 22 copper. And one of the questions from another fellow in the discussions was that the wire was way too small. However, we've made some other measurements, and then a fellow modeled it on neck 4, and it's not a problem. Of course, he has about 60 of them out there.
Fine.
But still.
The door's open. We'll be here.
Go ahead, Tom. We meet.
Okay. So the bottom line is, as long as it's copper, man, it's good.
Cool.
Right after Pacificon, you were gracious enough to build a PVC prototype of the ZR, sent me some information on it. You remember
Yes.
that?
Oh, yes.
Well, I put one together and it's very impressive. I took it over to a site that's on sloping ground overlooking a small lake and compared it to the buddy stick. And there's no comparison. It's unbelievable how well the ZR design works compared to the buddy stick. Very impressive. And I appreciate your efforts.
Well, obviously you did a good job constructing it. I've forgotten, how tall was that one?
Well, it's 4 feet between the two rings and it's 3 feet off, or it's 2 feet off the ground. So it's just
Right.
6 feet.
Right. I remember you did 4 feet. Yeah. Just had to remind me. That's pretty
Yeah,
short
that's great.
radiator.
I shared some of that information with some Bay Area guys, and they're gonna use a saltwater amplifier with it, see what happens. It ought to be pretty impressive.
Well, one of my favorite sayings is, once you use a good antenna, like a vertical by saltwater, it will recalibrate your mind.
You know, I one other question. I was thinking for field day, it might be very interesting to have two of those set up as a beam. You think that's a viable approach?
Done that many times. Team Vertical used ZRs on 40. They were only 15 feet tall. And we were in Jamaica, set it up as a 4-square. And I think the 40-meter QSO record is still there after 20 years.
Wow.
And we built those commercially for Globe Wireless. The first one we built, if I can take a couple minutes here, their classic antenna at the time, they had 80-foot tall telephone poles, and they were using 2 half waves in phase over each other in a V. So one V over another V fed in phase. And they ran 10 kilowatts CCS 24/7, shipped to shore. Well, the problem was finding locations where they could put these antennas up environmentally was really tough. So a friend of mine happened to work there, and he said, why don't you build them something and see how it plays? So we said, okay. So we picked a frequency that was around, they have weird frequencies. I think it was around 22 or 23 megahertz. And I brought it over there. It was a ZR. It was sitting in a 5-gallon bucket of cement. I only had a 3 kilowatt balance, so I asked if they could not run 10 kilowatts into it. They tested this thing for 1 month, 3,000 watts to the ZR in a bucket of cement, 3,000 watts to the big phased array. And this is worldwide. After 1 month, they said the difference was between 1 and 2 dB. That was it. And they said sometimes the stations could hear the ZR and not the other antenna. And after that, we built all kinds of stuff for them.
I bet you did.
Because it was so easy to put up, you know. We built them down to 4.5 megahertz even for them. So, and of course, they continued to test them too at all their sites. And that really felt good, by the way, to have this little thing sitting there on the ground, you know, compared to this big guy. But all their engineers said, can't work.
Well, the secret was the cement.
Yeah, yes. Actually, I think we put some RF sensitive plasma inside, but anyway. Any other questions that I can help you with? By the way, my email is really easy, just tom@n6bt.com if you want to zip me a comment or a question or whatever you might like.
Tom, I have a question. This is Bob, K6BC.
Yeah.
And thank you for a wonderful presentation. Most of us don't have the open space in our backyards to make any of these antennas work the way they're predicted to work. So what kind of suggestions would you give those of us that have trees, that have other structures? We're basically trying to do the best we can, but is there anything that is considered like a no-no in erecting either horizontal or vertical antennas with our limited space suburban lots?
Well, what I would suggest, when I suggest this, I would put up a ZR if you can. I even had one customer who had a similar situation like you're describing. He had a big hedge. He cut out a hole in the hedge and put the antenna in the shrub. And that's what he was using. And I've used them indoors. They work just great. And your friend over there in the upper right corner of the screen can help you even make one to test and see how you like it.
By the way, Tom, a lathe works wonders to take those 5 ways and convert them to 6 ways.
Ah, okay.
Everybody's got a lathe in their garage, right?
Oh yeah.
Uh-huh.
Yeah, just like I tell people, yeah, I still have a lot of equipment. Everyone should have a forklift. But anyway, back to Bob there. The other antenna you could make is what I call the Viper 98, just a single vertical part with a ring. And you can make several concentric rings and, put other wires coming off of that. So just find a space. If you have a space that's even 8 feet square, you can put this stuff up. But send me a note or a picture, something.
Sure.
And
Thank you.
we can figure it out. Did I wear everyone out?
No,
No.
no.
I have
Yeah.
a question.
Go ahead. Yeah.
I was wondering if we already have like a vertical that's fairly close to the ground and doesn't perform all that well, but we also have a metal roofed shed, whether mounting it up on the shed might make it perform better. And no, we don't have a bunch of radials on it. It's just sitting there.
Okay, is that like an R5 or something? R7?
I'm not sure the nomenclature. My husband put it up. So he always
Okay.
keeps track of the numbers. But anyways, it's multi-frequency trap vertical. So
Okay. My experience with those is that it probably will perform better. First of all, it'll be more in the clear, and the metal roof will give it something to work against.
would that
Might
be
give it-
considered? Would that be considered a counterpoise when you have it mounted above a roof like that?
I would not attach it to the roof. I mean, physically, yes, but not electrically.
Okay, so just have it so it's a reflector like.
Yes, just have it sitting above the roof.
Okay. Besides which, then you get more vertical, right?
Yes.
Okay.
Hi, I have a question. Tom, I'm Carol, KP4MD. And
We've never heard of you.
really,
Yeah,
okay.
it's just multiple choice. The answer is B.
Yeah, I started out with a screwdriver antenna. By the way, I live in also antenna restricted. I live in a mobile home. And my lot here is like 50 feet by 60 feet in size. And the first HF antenna I put up was a screwdriver antenna on the roof. The mobile home has a metal roof. It has aluminum siding, and it made perfect sense to use that as the counterpoise to avoid the problems of running wires all over the place, and having the wires so close to the roof, of course, would affect the length of them and all that. It worked pretty reasonably. And then I decided I wanted to get an antenna that was a little bit more broadbanded, that I didn't have to adjust very carefully when I was down on 80 meters. So I also put up a full wave horizontal loop, 40 meters. So it's about 35 feet on each side, and it's up 20 feet high. It's a very thin wire, so it's also low profile. I found out that you could imagine that wire goes around the perimeter of my lot here, and the vertical being right on the house, they are within the near field of each other. And that was quite an experience, having an alien antenna experience when I would tune the vertical to a particular frequency. It had a major effect on the tuning on the performance of the loop antenna. They were just so close to each other. And I was just curious. I put a number 47 light bulb on the end of the coaxial cable of the vertical when I transmitted into loop 100 watts, and it lit up the bulb. There was that much power being transferred from one antenna to the other. And that made me concerned that if I left the radio connected to both antennas, that one could damage the other. I also noticed that if I'm listening on the loop and I'm tuning my screwdriver antenna, if I bring the frequency of the screwdriver antenna anywhere when I'm listening to on the loop, it has a major effect on the noise level that I pick up on the loop. So it looks like the coupling of what I'm getting on the vertical antenna is going into the loop because of the closeness. It's But I think the word of warning there is if people have antennas that are within the near field, they should be careful not to leave radios connected that might possibly damage
Yes.
because of the coupling.
Yeah, that's a really good example of
Interaction. Yeah.
well, yeah, destructive interaction. Now I got a question on your screw drive. What is the vertical part right at the top? What material is that?
Okay, yeah, that is stainless steel.
Okay.
It's a stainless steel. It's, you know, the loading coil is actually center loaded. The part below the coil is aluminum.
Okay. If you can get some tinned copper braid, you can actually buy it from Amazon and put that over that top radiator. You'll find your antenna is a lot more efficient. I realize that's probably a fair amount of work, but you won't be disappointed.
Yeah, that's interesting. I might try that. One other thing I noticed when I'm trying to work like some of these DXpeditions, they can hear me if I'm transmitting on the screwdriver, where many times they won't hear me on the loop. And I guess that's definitely because the vertical has a much better low angle takeoff.
Well, they may be coupling into each other,
Mhm.
and one's helping the other.
Mhm. Thank you.
If I could invent one more thing, it would be an RF sensitive spray. You know, you get a spray can and just go, you know, spray it and say, oh, well, there's the signal there, you know.
That would be fun fireworks.
All right. Anyone else? Ask away. I realize they have your business meeting after this, so
Oh,
sorry about that.
well, we got
You're a lot
time.
more interesting than the business.
Yep. Tom, when you talked about doing your measurements with a drone around the antennas that you're testing, could you talk a bit more about that? How does that work?
Expensively.
Okay.
Yeah, the last drone I crashed was a unique. I think it was about $2,400 worth.
Ouch.
Yeah, well, just a massive power failure, and it just fell. The 4K camera, I don't think I can salvage. I think I can rebuild the rest of it, but anyway. And the first one I flew into a guy wire. But essentially, what you have to do, well, one of the problems today is that most of the drones do their controls on 2.4 gigs, and then telemetry on 5.8. The first one I had was a 3DR Iris Plus, which was really the best one because it ran at 900 megs and did the telemetry on 2.4. So I could fly that around anywhere that was running, you know, Wi-Fi stuff, not a problem. Well, I also, the third one that I have now is a DJI, and it actually will come up on the screen and tell me, oh, you've got, you know, got a lot of interference here, and it will actually shut down the drone. But all that interference stuff aside, it's also necessary to take your signal source. We do it in reverse. We fly the signal source and receive on the antenna under test. The signal source is an Elecraft XG3 signal generator. It's light enough so that most drones can take it as a payload. And the catch to that is it has to be far enough away from the drone because it's transmitting. If you have it too close, it will also screw up your drone.
Right.
So we usually have it tethered about 2 meters away. Even when it's running full power at 1 watt, it won't bother the drone. The other thing is that your drone telemetry has to be able to read minus altitude. Now, for most people, if you're flying a drone, you do not want to have a minus number there because it means you just crashed. But if you're flying through antenna patterns, you know, you're flying the drone down a slope, you start at the top and you fly out there and you want to make, you know, you want to see what it is in a negative direction. So The other thing that we do, doing that makes it very easy, relatively easy to figure out takeoff angles. Of course, you have to be correctly polarized also. The nice thing is that to create polarization doesn't take much. If you go through the old equations, you'll find that actually, if you take the antenna off, the spaces on the board are enough to create polarization, depending on how you have it oriented.
Okay.
So we just plug in a short antenna and actually have an antenna long enough to get enough signal for the antenna under test. And the farthest we've done, we go out to 1,000 feet. And the reason why that's kind of the limit is that technically the height limit is 400 feet.
Yeah.
And so if you do the geometry, that tells you, we can only measure up to a certain angle, whatever that is, 30 degrees or something. But so you need to get the polarization correct. But again, that's pretty easy. Make sure it's tethered far enough away from the drone so you're not going to destroy the drone. And make sure that you don't have any other interfering signals, because you can be flying along and suddenly your drone will do things that you don't know. And I should make one other comment. Before you try to fly one of these drones, they weigh 4 or 5 pounds and they can fly 40 or 50 miles an hour. And the propellers are really sharp, whatever they're made out of. And the last thing you want to do is have one come after you, or worse, after somebody else. So learn how to fly a really cheap one. Get one like for $40 or $50. Fly it inside your house. And once you can take it down the corridors and in and out of doorways, then you're really probably good to fly the big one outside. Because even with all the time I've flown them, one time I had one lift off and it got up about 6 feet and came right at me.
Wow.
So the question is, what do you do? The answer is altitude saves you. You just hit full throttle and get it up in the air. And of course, I went the other direction. But just need to be aware that these things happen. And we do not fly when there are other people around. Some of the places we've flown at, like at a place called Back Bay in Los Osos, we go there very early because you tend to generate a crowd. Oh, someone's got a drone. What are you doing? Well, it's hard to say, I don't want you here. So we usually have a couple people just to talk to them and keep them back, if it's a kind of a place where we might have visitors.
Got it.
So then, sorry, one more thing. If you want to compare antennas, antenna A, antenna B, you cannot do it with a single source or a single receiver. You also need to have what we call a candle, like from astronomy. So what you have, you have the antenna under test and you have a candle off way to the side or the back somewhere. And that's actually your key to your transmit level off your drone, or if you're using a static level. So you have coaxes going to the antenna under test and also to the candle, and you actually end up measuring the difference to the candle instead of from one antenna to the other. It's how much difference it is with the candle. So that keeps you honest, because sometimes things happen. Okay, I know that was kind of long, but there you go.
That's good. That's interesting. Thanks.
If anyone would like to try to repair one of these drones, let me know. I'll give you a good deal.
Get in line. I broke mine too, trying to do the same thing.
Yeah, kind of get that sinking feeling when it just is falling,
Yeah.
Yeah.
I have a DJI Mavic drone with
Oh.
I had the payload for it was only 2.5 pounds, which is more than was registered to do in the first place. But I tried to get an antenna up in the air, and yeah, no, it only does so much. It only does so well.
Yes. And you have to be careful not to overheat the batteries.
Yeah, because they do get a little bit warm, but there's always warning on the screens. The big thing I had a problem with is the wind. It was kind of hard to keep because you're tethered in some sense, so it's fighting the wind and all of the resistance of of the wind carrying the antenna or the wire.
Yeah. Now, did you have one of the remote releases on there?
I wasn't that smart.
Oh. Okay. There are remote releases available for
Yes, there are.
doing that. Okay.
Yeah, no, yeah, it was my, again, it's a Mavic drone. It's the one I use just for photography and hobby. And hey, let's just double purpose it. I'd like to get an antenna up in the air and see what this looks like. Yeah,
Oh,
the wire is too heavy.
You just need a bigger one.
Exactly.
About 5 times the price.
Yeah, well, mine was kind of it was $1,200, but then it finally met its fate at a tree. But it's time for a new update, and yeah, they're rather expensive, so I'm saving up my pennies.
Yeah. Okay. All right. Anyone else?
Tom, thank you for the lecture, guy. It was a very good lecture. I learned a lot from it.
Thanks. All right. Well, again, I appreciate your time tonight, and enjoy the rest of your evening.
Thank you, Tom.
Thanks. Well, thanks for spending the time with us. That was a great presentation. Thanks.
All right.
Thanks, Tom. Really good.
All right. So moving on to our club business then. Jojo, he had to drop off. So he shared his treasury and membership update. So I can do a quick share on this just to cover it quickly. Let's go over here. Let's see. Let me know when you can see.
It's up.
All right. Okay. So update from Jojo. On our membership, we've got 168 members right now, 11 live, 135 regular, 50% are paid up for this year's dues. The club also voted to award Phil, KD6RM, life membership for his contributions to the club. So round of applause for Phil, and thanks for everything that you do for the club. As of April, we had 122 members. Oh, I guess that's a comparison to where we are now. Okay, all right. And then let's scroll forward a bit. And then Jojo says for treasury right now, we have 6,438.70 in the general fund. Repeater fund is 2,328.65. Total balance right now is 8,767.35. And there's a couple of thank yous down here. Gary, WA6FGI, latest new member. Thanks, Gary. Thanks for joining. And thanks also to David, KM6GYM, for your December repeater donation, if you're on with us tonight. And let's see. We should probably include these extra details that Jojo includes in the club newsletter as well. So I'll talk to Jojo and see if we can get these extra info pieces in the club newsletter. Do that for next month. All right. Carol, are you still on? Can you do a social media and website update for us?
Sure, I'll go ahead. I'm going to go ahead and share my screen. By the way, Happy New Year to everyone. Let's see. Well, here it is, down the bottom. Okay, can you see that okay?
Yes.
I don't know.
Yep.
Okay, thank you very much. Well, this is a report of our web resources for the month of December. And let's see, how do I, there we go. Just a reminder that our URL for the website is n6na.org. And we have the new mobile-friendly format. And we're doing a good job of keeping this up to date. I want to thank especially Tom, Kevin, Jojo, and Sylvia, who are part of the website design team. There are a number of pages that are still have problems with the formatting, and it's just the appearance of the pages got a little bit jumbled after Google Sites decided to do a conversion of the website platform to make it more mobile friendly. So the major web pages that are mostly visited are pretty much fixed up. There are some other, we have a total of about 35 pages on our website. If you drill down, and some of them still need to be fixed. They may look a little bit jumbled, but all the information is there and we'll eventually get to them. There's no big rush on doing it, but it's just to show you that a lot of hours have gone into this website, and we appreciate the help of everyone on the team. And a reminder that our nets are Wednesday nights. So tomorrow we're going to be having our 2-meter net at 8 p.m. on the 145.25 repeater. You can get into that net also via Echolink and the All-Star node. And then at 8:30, we have our 10-meter net on 28.420 megahertz upper sideband. Everybody is welcome to check into that as well, regardless of your license class, because that is legal for technicians to use that frequency as well. And then at 9 o'clock, we have our slow scan TV net, which also live streams on YouTube. And Wilson does a wonderful job, N6EMF, as net control, and I help with the doing the streaming of the video there. So website activity for December. We had a drop in the total page views from 2506 down to 1836. And I believe a lot of that had to do with a lot of those views during November were from people doing editing of the website, because every time you go in to edit it, it counts as a page view. So this does not really reflect the loss of interest in the website. It's just a little bit of decrease in the editing activity of the website. Most of the web page views were on December 1st. And our most active web pages are the home page. We had 735 views. Then the membership application page, which makes perfect sense because it's time for people to update and renew their memberships. And when you haven't done it yet, you certainly are welcome to go on the website. And we do request that anyone who's renewing, especially if they have any information that needs to be updated, to go to the application form and mark it as an update and a renewal as well. The nets page had 61 views, people interested about our nets. And then the About Us page had pretty good number of views. And that's good because I guess that reflects that there's an interest of new people want to learn about our club. And it's been reflected by the number of new members we have in our club as well. And then the repeater page as well. So the source of many of our hits, we get a lot of referrals from Google, 36.7%, but the majority of our hits were directly to our URL, which is n6na.org. And most of the hits, of course, the page views were from California. We had a number from Washington State, a number from Arizona, and a few views from all these other countries as well. We always have visitors from other countries that like to look at our website. Social media, the YouTube channel now has 746 views in the past month, and our number of subscribers has gone up to 354. We have a Facebook page that has 552 followers. Twitter page has 145 followers, and we have a Discord chat that now has 24 members. We brought on 3 new members to the chat server over the last month. And just a reminder, if you want to contact anybody here among the board members or any of the officers, or even any information for the web design team, you can send an email to contact@n6na.org, and it will be directed to the appropriate person. Also have URLs for our different social media feeds as well. So that's it for the month of December. And I want to thank everyone for a wonderful year 2021. And we're looking forward to a promising 2022. Thank you very much. Back to Kevin.
All right, thanks, Carol. Thanks for the updates. Does anyone else have any other comments or news items or anything they want to share tonight?
I've got a couple, Kevin.
Yeah, go on.
This ZR antenna that Tom was talking about, I built a prototype. Mike, that GFM, K7 GFM is actually, have you finished yours, Mike?
It's within about 10 minutes of being finished. I just have to solder on the coax connector and give it a try.
I've prepared a presentation on building that antenna. You can't believe how simple it is to build. And as Tom documented, it's quite a performer. It's only, the arms are 40 inches long, it's 6 feet tall. And I built it for 20, 17, 15, and 10. It's single band, but to change bands, it's a simple procedure. You just remove one piece of wire and stick another one in, or you could actually do it with a jumper kind of arrangement. So that's kind of a tentative thing for our March meeting, if that agrees with everyone, Kevin.
Yeah, definitely. Yeah, it's interesting.
And the other thing, I've been working on a 3-element 2-meter beam. Can I do a share screen?
Yeah, sure.
Let me do a share screen here. And what I need to do actually is maybe I screwed this up. Should have had this up and running. Let's do this. Can you guys see that?
Not yet.
Not yet.
It doesn't appear that it's sharing, Phil.
Trying to figure out where I'm supposed to be here. Can't seem to get back to.
I have a question for you, Kevin, while he's looking for that. As a host, how do you allow a participant to share screen?
On the bottom row of the Zoom app, there's a security button. And in there, there's a list of items. And one of them is allow participants to share. And that for us, I don't know if that's how our account is configured, but that's normally turned off. So I go into there and I turn it on, and then anyone can share.
Okay, I need the information for another meeting. Thanks very much. Back to back you.
I'll take a
Kevin, can you
screenshot.
see
And
my
I'll send you an
share
email.
now?
Yeah, we can see. Yep.
This is an SWR curve on my prototype of that 3-element 2-meter beam. I think you can see that we're a little over 3 megahertz bandwidth for a 2-to-1 SWR ratio. And I did a little tuning on this thing, and I actually got it so it covers the entire 2-meter band. When we were first talking about this, I was talking about, we could build a beam for $5. Well, as per Tom, the cost of aluminum is through the roof. We're looking at closer to $25 to do one of these things. The commercial version of this antenna sells for $150. So at this point, I guess the question is, do we have anybody interested in building one of these beams? They're all machine pieces and parts. It's a pretty professional looking product. But there's no point in going further if we don't have some guys that want to build them. And frankly, we need about 10 builders for it to make sense. Any comments?
Yeah, would we want to always make it in 2 meters, or would we want to go like to 10 meters or, another band?
It's just strictly a 2-meter thing. It's vertically polarized antenna designed for hitting into repeaters or working mobile stations.
Okay.
PGQ has an interest. Well,
I'm interested.
You're interested in it too?
Yeah.
All right, Jane.
I'm interested. I just was curious about how it translated to other frequencies, but 2 meters I'm interested in. Yeah.
So we may have 4 or 5 at this point.
I'm interested.
Sylvia. Was that a Sylvia that wanted one?
She does.
Holy smokes. Bob wants one. Cool. EMF.
And I'm interested.
Well, I'll continue with it. I got to do some shopping around. The key is trying to keep this price down as low as possible. But I think you'll be impressed with it. Did you like that SWR curve? That's pretty nice, isn't
It's pretty. It's almost pretty enough to hang.
it? People have said that about me a lot. Pretty enough to hang.
If Phil, add me to the list.
Add you to the list? Okay, Neil.
Yeah.
I got a question, Phil. Would you be able to add 440 to that?
No.
Goes both ways, huh?
I mean, that's quite a design criteria. I just don't have those capabilities. The problem with that kind of thing is you really need an antenna test range to verify the performance. I do not have one of those. So if you've got a good design that you can copy, it's conceivable. I copied an M² antenna to put together this thing because I know that the performance measures up. But I have no way to include UHF with it.
Well, Phil, I'm interested, and I have a question. What about machining the parts? Is that going to be complicated or easy?
Oh, no. I have a machinist. I don't know how many of you know this, but Gert is a journeyman tool and die maker. I've got a little tiny baby milling machine at home. I can remove about 25 thousandths of an inch of material per pass. So, it's about a week to carve out a part. She's got the real machine. So we can knock these suckers out.
Sounds good.
So there's no machining involved for anybody putting one together. It's just, we'll have some stations set up and we just walk right on through, put them together, and then I'll tune them. And they'll all come out with an SWR curve that looks like that. It's a nice package.
Any other information about on the prototype for HF that you put together? Is that a potential plan for future?
Well, let's see how VHF works first.
One project at a time, huh?
One's enough at a time, trust me.
But there is a feasibility for it.
Well, it's certainly possible. Again, I'd have to do some digging around. Once you get into UHF, things become a lot more critical. For example, on 2 meters, if you shave the element by 1/4 of an inch, you shift the resonant point 1 megahertz.
Wow.
So you get to UHF, it gets really delicate.
Well, I was thinking about HF, your prototype HF, not UHF.
Oh, that's the ZR?
Yeah.
Well, the ZR, you can build it for any one of those bands. In fact, it'll work on all 4 of those bands, no problem. And I've actually prepared a complete set of specifications, dimensions, how to go about it, how to get the pieces and parts. It's duck soup.
Very, very interested.
Yeah. Neil.
Yes.
You reminded me, Hank was wanting to email something to you, and your email that I had in my an older membership list didn't work. Have you changed it in the last year or two? Or
No,
it's
very simple. Neil, Neil, dot my last name, Gimenez, and you can find that on qrz.com at gmail.com. So I'll contact you directly. I'll look at QRZ.
Okay. That would be helpful. Thank you.
Sure.
One thing about the 440 antennas is the diameter of the elements is a significant part of the wavelength. So those antennas tend to be pretty broad banded, and they're not very critical with resonance. So that's one thing positive for 440. And Kevin, I just wanted to ask you to look at your chat, because I sent you a direct message about some club business. If you would take a look at that now.
I took a look and replied. I think we're good.
Oh, so shall we proceed with that today?
No, we did it via email.
Oh, we did it already. Okay.
Yeah. I think we're good. Unless there's something I asked about in that chat that I'm not aware of.
Okay. Did that require a membership vote?
That's what I was asking.
Yeah, it does
It
generally.
does.
Yes.
Okay, we could do that now then. Okay, so for the life membership for Phil, we need to take a club members vote if we all approve that it's okay for us to award Phil the life membership. So could we do like a thumbs up or a chat message or something? I think I can see a lot of thumbs up.
For
Consider
sure.
it done.
Yeah, there we go.
It's a done deal.
Lots of thumbs up. There we go.
We,
Yeah.
we know a winner when we have one.
All right.
We all got the $50 check that he sent to us.
Yeah,
There you go.
for sure.
All
And
right.
Gert, I sent you a private message with my email address.
All right.
Congratulations.
Close it then. So congratulations.
You know,
Phil.
while we're talking business, does everyone know that tentatively next month's meeting, we're going to have Hiroki do a presentation?
No.
I don't know if you guys know about this. Hiroki is a fella down in the Bay Area who actually grew up in Hiroshima.
Mhm.
He was 3 years old when the bomb was dropped, about 20 miles from where he lived. And a year later, he was going to school in the town of Hiroshima. Ham radio guy, very accomplished man, and he is a nut about clandestine wartime radio equipment. And he's got all kinds of stories about that stuff and all kinds of examples. He's made several presentations over the years at Pacificon on that topic. And he's scheduled to be our speaker next month. I think you'll get a kick out of him. He's quite a guy.
So what specifically is he going to be discussing? The clandestine radios
Clandestine radios, yes.
during a particular time? Was that during,
During our normal membership meeting.
I mean, what time was it? Period of World War II clandestine radio or otherwise?
To the best of my knowledge, it's World War II. How about wartime clandestine radios? We can't miss.
Okay, thank you.
And for those who do not know, he was on the cover of QST so a few months.
Yeah, he's quite a guy. And he's got a squirrel zapper antenna.
Mhm.
Not everybody's got one of those.
I do have the squirrels. So.
It's the railing of his balcony. Yeah, I saw that.
Isn't that too much? That's all I have.
All right. Very good. Anyone else have any items for tonight?
Great program. Thank you.
That was a good one. Yeah. Yeah. Thanks, Tom,
Tom, you
for
did
getting in
great.
touch with
You
Tom
did
and getting
great.
him to present for us tonight. That was good.
Yeah, I'm always interested in what he has to say. I mean, if anybody gets a chance to go to Pacificon and you're still working, take a day off and go to the Friday antenna seminars. You'll find a lot of people that are really smart and know a lot about antennas, and Tom is one of them.
He when he mans his booth, you can ask him any question you want. He'll talk to you for hours. Really a nice guy.
Well, good night, guys. I'm gonna leave, but our thoughts there with Mike. Hope he recovers. Good
Yeah,
night,
I
thanks.
hope he's doing better. Sounds as though he's getting better.
All right.
Okay,
Ready to wrap up for tonight?
let's wrap it up.
All right. Thanks, everyone. Thanks for joining.
Thanks,
Right,
Kevin.
See you again
Thanks,
next
everyone.
month.
Good night.
Thanks. Bye.
Bye, all.
Bye.
Thanks and bye, guys. Take
Bye.
care of yourselves.
See you. Bye.
Bye.